All right, so 5.3 is broken up into two parts. So 5.3a and 5.3b, you can relate them to being the easier version and the harder version if you'd like, but I'll be honest, this is all just kind of hard. So we're going to take really good notes today. What happens is kids are so focused on the trig aspect of what we're doing that we forget how to like do basic things like take the square roots of equations, and we forget how to factor all of a sudden, which is very sad. So this is what we're going to be faced up against today, guys. I'm going to ask you things like cosine of x equals 1/2. Please solve that equation. So if you want a visual representation for what we're looking at, here's a cosine graph drawn by a computer, not me. And then here's the line 1/2. How many times are we going to see an intersection? And a lot. Yeah, the answer is a lot. So if I asked you to give me all the solutions, that would be a really difficult question to answer at this moment. But if I said, just give me the answers between 0 and 2 pi, well, I could find those pretty quick, and actually I could find them off the unit circle. Go take a peek at your unit circle. What values on your unit circle give you a cosine of exactly positive 1/2? I'm guessing it's pi over 3 and 5 pi over 3. And those would be the two solutions between 0 and 2 pi. But what if they were like, oh, never mind, I want all of the solutions? Well, this is what's going on, guys. I'm going to give you a little weird unit circle picture for a minute. Really crude one, apparently. So this was the first time at pi over 3, right? And then down here was the other guy, which was 5 pi over 3. And every time you made a rotation, you would land back in the same spot. So like pi over 3 plus a rotation, all they're going to have you do today, looks complicated, but it's not. They're just going to say, slap a 2n pi in your book. Abruzzo does 2 pi n. I don't know. The n stands for any integer. So sometimes you'll see teachers write 2 pi k. That means the same thing. So integer being a positive or negative whole number. So like 1 rotation, 2 rotations, 3 rotations, -5 rotations. Any rotation integer number you throw in there, it's going to bring you back to the same spot. So if they wanted all solutions for this entire problem, you would have to slap that plus 2 pi n onto each one of your answers. And we'll talk later today about how your book tries really hard to give what they think are more efficient answers, like this. Can y'all look at this for a minute? This is what your, whoops, hold on. My pen's not working. Just a moment. It's thinking about it. Okay. This is what your book thinks the more efficient answer is. Because it's like less writing. So what happens is you would have to recognize, okay, this is negative pi over 3 and this is positive pi over 3. And you can just slap rotations on one, like written form of that. This is what your book thinks is the best answer. Mrs. Abruzzo thinks these are the best answers. They require less thinking. Yeah, right? You're on board with this. Star didn't seem on board with less thinking. Maybe they were just being ultra quiet today, but I don't know. Right? I don't want to. Oh, here's my point. My answer key today, I did the lazy Abruzzo thing where I just slapped 2 pi n on the end of all. If you look in your textbook, if it was an odd problem and you look in the back, they very likely might have an equivalent, but what they think is a prettier answer. I don't care. They're both right. I'm kind of voting for the less work today. That's where I'm at. It's like a fake Friday. Y'all got to go get ready for your Valentine's Day tomorrow. Not tomorrow, it's Friday. Oh my gosh, I told my kids tomorrow's Valentine's Day. I'm so wrong. I'm so wrong. Oh man. Yeah, right? Valentine's Day Eve. Oh man. God, why am I off by a day constantly? All right. So here's what we're going to be doing today. We're going to be solving what they consider to be basic equations, but guys, there's nothing basic about today's work. This is tough stuff. So as we take notes, we're going to kind of write down prompting words that will help us when we get to the homework. I'll show you what I mean later. So this first question, this is done for you. So you don't need to look or write down anything. You just need to watch me on the board. So the equation is tangent of x times cosine of x minus cosine of x equals 0. And they want you to give me all the answers between 0 and 2 pi. So I need to like put on my algebra hat for a moment and think, how would I solve this equation? And your silence is the right answer. You're like, I don't know how to solve this equation. There's just a lot going on here. It's a mixture of different types of trig functions, which is very exciting. I noticed it's set equal to 0. This is a good candidate for what we know as factoring. So if I think about how I approach a factoring question in algebra, I first look for any common terms. Well, your common terms today could be trig functions in addition to numbers. So do you see any common terms between this? Yeah, there's a cosine function. So you can factor out the cosine function. And when you remove it from this equation, this expression side, you still have tangent of x and then minus 1. So that's not like a typical go-to, like, yes, my algebra instincts told me to factor this. That's what we're trying to develop today with our lesson and our homework. Yes. Oh, like switch it to sine over cosine? I don't think adding fractions to my life right now would make me happy. That's a great question, though. We will have some coming up where I do want to do some trading, but that's the harder stuff at the end of the lesson. So for now, no. So now I think about what happens when I solve a quadratic, in past experience, when I set it equal to 0 and I factored it, then I take each of my factors and I set them equal to 0. They take their turn equaling 0. So this one, I'd write out cosine of x equals 0, which is great news because he's ready for me to take a peek at the unit circle. Hold off though. And then this guy, if I set it equal to 0, I would get tangent of x minus 1 equals 0. This one needs a little bit of work. I'm not ready to look at the unit circle yet. I'm going to add the 1 over. And it's going to say tangent of x equals 1. Now it's ready to look at the unit circle, which means we go look at the unit circle. All right, so go take a peek at your unit circle, guys. Where do you see it giving you a cosine value of 0? At pi over 2 and 3 pi over 2. Where do you see, and this one takes a little bit of brain power, where do you see your tangent function coming out to a 1? Now, remember, tangent is, like Piper was pointing out, sine over cosine. So the places where you're going to get a positive 1 tangent would be the pi over 4 family, only in the quadrants where he is positive, so here and here. So that would be pi over 4 and 5 pi over 4. And then if I wasn't a very diligent child or student or teacher, I would be like, boom, there's your 4 answers, and I'd walk away. But this one has an extra twist of fun. This is very unusual. I need you guys to remember what I feel about tangent. I hate it. Tangent is my nemesis, and he screws with the problem all the time. Tangent is undefined at 2 places on the unit circle. Where is tangent undefined? Here and here, right? This is the ordered pair 0, 1, and this is the ordered pair 0, negative 1. So if you were to find tangent at pi over 2 and 3 pi over 2, tangent is undefined. So think of this in terms of like your experience with algebra. Part of your solution end up, like when you plug them back in, you get something bogus, like a divide by 0 undefined thing. Those answers are extraneous. We have extraneous solutions here. I can't use these because tangent is undefined. These are the only 2 solutions that work for this equation. That was incredibly hard, okay? The fact that twist at the end with tangent. So all I wanted to do on that question for you guys was to A, recognize that you could factor out a cosine. You guys caught that now that I pointed out to you. Remember when we factor something and then I solve it, I set each of them equal to 0. And then that twist at the end with tangent, that might show up again. It doesn't show up very often. We just have to remember that anytime tangent shows up today or on Tuesday, if it's pi over 2 or 3 pi over 2, that's garbage. I gotta throw it out. Okay? Tangent is a problem. I think we've all come to that conclusion. Tangent. So the next one, oh, by the way, I like these answers. In a minute, they're going to talk to you guys about all solutions. So if I change the directions on that problem to say, give me all the solutions, think about the 2 solutions you just gave me. You gave me this guy, which is pi over 4, and you gave me this guy, which is 5 pi over 4. Right? Do I have that right? So earlier, we learned that Mrs. Bruzo is very lazy. And if the directions were changed to all solutions, she just would have been like plus 2 pi n plus 2 pi n. And I'm still okay with that. If this is what you do on your homework and your test, love it. Actually, that's what my answer key says. So you'll match my key. But there's some very thorough children out there who are like, there's a much easier way to express those solutions. And I'm like, all right, kid, go ahead. They said, well, if you just add half of a rotation, you're just going to keep coming back and back and back to the place where you want to be. So they're going to say, true efficient answer is pi over 4 plus pi n. Why pi this time? Pi is half of a circle, yeah. Well, that's a great question. You don't have to put plus or minus because n is an integer, so n itself can be positive or negative. If you put plus or minus pi n, that's fine. I know what you mean. You don't have to. So that's what like your textbook would have given as the answer for all solutions. But the one up above it that looks like Christmas colors, that's Mrs. Bruzzo's answer, and I think those are better. Sorry, book. Because I didn't have to think real hard. You know I'm a big fan. All right. Let's take a peek at the next question. Again, this one's already done for you. Yep. Let me show you what's going on. So you're gonna find problems like this in your work, in your homework tonight. And you might not be like sure where to start. So if you really, really are stumped and you cannot figure it out, I did put prompting words on your answer key. So on your answer key, I wrote the word isolate on this question. Isolate. And here's how I know we have to isolate. I'm looking through this question and I see just a sine function. I don't see anything else. No other functions. I don't see a sine squared, sine. So when you have an equation where there's just a singular function, not squared, not something else with it, you just got to isolate the sine function. I can do that. I'm going to add the sine over here. And while I'm isolating, I'm going to go ahead and subtract the square root of 3 over here. So that gives me 2 sine x, when I add those together, equals negative square root of 3. And I'm not quite isolated, right? Isolate means to isolate the sine function itself, so you gotta divide both sides by 2. So now my question says sine x equals negative square root of 3 over 2, and I am ready to look at the unit circle. So go take a peek at the unit circle. Where, no, I need negative this time, so be careful. Where is your sine gonna come out to negative square root of 3 over 2, and methinks it's like here and here, which are, love it. And it just said, oh, no, it didn't. I thought it said 0 to 2 pi. Back up, back up. Time to get lazy. This is what a Bruzzo's answers look like. I list them out separately at first, just like Piper telling me. And then, oh, so lazy teacher goes plus 2 pi n, plus 2 pi n. That's my answer. Yeah, for the lazy person way, yeah. If you try to get creative and you're like, oh, I think I can figure out a better way to say this, you might not match my key, and you're probably right. I just don't know why you'd go to the effort to do it when I'm telling you not to. There's always some weird kid out there, though. Because that, yes, but that just made me angry. Right? I'm gonna be all grumpy, like, argh. And actually, I don't know if that one even had an easier way. Because I don't think it did. It wasn't off of 0. Well, it either have to be an even cosine function where it's stemming to the first and fourth quadrant, where you can do plus and minus, or it'd have to be a half rotation one. Yeah. So if you don't have those two causes, like even or oddness, then don't think about it anymore. So this one is not done for you. Finally, something we can look at. This one's really boring, guys. You don't have to do anything. You're just ready to look at the unit circle. Now notice it does say all values of x. So tell me, start with just one trip around the unit circle. Where are the places or place where cosine is equal to -1? Yeah. But it does want all solutions. So then your lazy teacher goes plus 2 pi n. Yeah, that's it. So if there's like 4 places on the unit circle for one trip, you write all 4 of them out. We're about to see that. And then you just put 2 pi n on each of them. Yeah, that's lazy person technique. And I think we should all be lazy here on a Valentine's Day Eve. And then just draw an arrow down because you're too lazy. They're not. The ones we're about to do are not. So, yeah. They're not always. All right, let's look at one that's a little more exciting. Oh, before we get to something exciting, I need you guys to remember everything you know about algebra from up until this point, okay? You got it all in your brain? All right, so question. In algebra, okay, I should make something up that works. Ooh, that's 5. No, that's, okay, hold on. X squared plus 5x equals -6. How would one solve this? You can't factor yet. Yes, you have to set it equal to 0 before you investigate any factoring, children. See, this is what I'm talking about. Y'all get to PreCalc and you're like, I figured out how to solve a quadratic. Okay, so we're not going to continue, but the point here is, yes, you need to set it equal to 0 before you investigate factoring. For some reason, right, so for some reason, kids forget that in this high-level math. And you're not the only one, kiddo, trust me. This happens a lot. Now, what about this question? You would square root, and what'd you get? Wow, that pressure really got to you guys. Okay, so the thing I was hoping you wouldn't forget, which you totally did forget. So some of us are going to forget when we square root an equation, regardless of its nature, the answers are both positive and negative, and then square root of 4 is just 2. So can you remember everything you know about algebra now? It's all up there. I gotcha. All right. So then this is my favorite one. All right. This is a little note from Hofbauer. We see this every single year. Kids get this question, and then they're like, ooh, you know what? I'm going to add sine over. And then we're like, okay, cool. Why? And then they're like, well, because I'm going to go through and divide everything by a sine. There is so much wrong with dividing by sine. Okay, first of all, okay, so the problem, it's the same. It's this idea. You get kids who do this. Mrs. Russo, I divided by x. What happened? You got rid of an entire solution. You lost half of your solution just by doing that one illegal move. Whoops. Because you lost a solution. What are the solutions to that problem, Daniel? You're supposed to factor out the x, right? Your solutions are 0 and -3. You're only going to find -3. What about 0? Okay, the technical mathematical reason why you can't divide by a function, or in that case, a variable, besides the fact that you're losing a solution. What about the case where sine is equal to 0? You just divided by 0, and you just created an undefined mathematical, I hate to say the phrase, but black hole. Calm down. That was a good plug for you. You missed it. We know we're not allowed to divide by 0, and you kind of just did. Oh boy. All right. A new rule where I can just make up math. If everybody else makes up math, so can I. Right. You can. It's called a conjecture, and you can get it proven by the mathematical community. Go ahead. That's what people do in college. Those professors who are doing stuff, they write things, and then they decide to discredit them or not, and then you get something named after you at the end of it. Pretty cool. It gets published. Okay. E, the natural number, or capital E? Capital E. MC. All right. Finally, guys, we got a problem that is not done for you over here that's going to take a little more teeth than what we just did on the last question. So, here's what I notice. I've got sine, but I do notice sine to the third and sine to the first. I can't do any combining, so I can't isolate. This is a good candidate for factoring. Put down a prompting word to yourself. We're going to be factoring this. So the first thing I check, my algebra brain says I can only factor when it says equals 0. Does it say equals 0? Yes, so we're ready to factor. So I think about my algebra factoring experience. The first thing I do is look for a common factor. There's a common factor here, guys. What is it? A sine function, factor them out. If you factor out a sine, you're still left with sine squared x minus 4. And now it's take your turn equaling 0 time. You have this factor, and you now have this factor. And you're going to set them both equal to 0. So sine of x equals 0. I'm going to leave him alone for a moment. He's ready for the unit circle. Let's take a look at this guy. Sine squared x minus 4 equals 0. This one takes a little bit of algebra work. First thing I'm going to do is add the 4. And then I'm going to square root both sides. For a moment, Daniel. What do we got? There you go. Great. So actually this one's ready for me to think about the unit circle. We'll come back to that one in a minute. Back to me, and it does say all values, so keep that in mind. Every place on the unit circle, you should find 2 of them, where sine is equal to 0. Call it 0, but I know what you mean. 0 and pi. Find all the places on the unit circle where your sine is 2 or negative 2. 4. Is it? Because I'm thinking about sine. And I'm thinking about sine wiggling between 1 and negative 1. Here's 2, and here's negative 2. There are no solutions here. This is garbage. So, if this was my final answer, I'm going to be in a bit of trouble, because it did say find all solutions. So the lazy Abruzzo kids are just going to go plus 2 pi n plus 2 pi n. And then the go-getters out there in the world, they're going to do something else. This is, yeah, well, here's what they're going to do. They're going to say, and a visual would be good, right? So here's 0 radians, and here's pi radians. And they're just going to keep, like, floating between them, like, whoop, 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 whoop. So they're going to come up with an easier way to express those solutions, and they're going to say pi n. Which is simpler. I'll give it to them. That one's simpler. But, like, the act of me thinking about it was not simple. So, like, n was any integer. So negative 1, 0, 1, 2. If I have to land here and here and here and here and here and here, it would be every rotation of pi. So 0 pi, 1 pi, 2 pi, 3 pi. Half of a rotation of pi. Yep. Instead of 2 pi n, it's pi n. Yep. I'm with them, guys. That is totally a simpler solution set. I just don't think the act of you finding it is worth your brain power on Valentine's Day Eve. Because you're going to do your homework tonight. That wasn't a joke. All right, number 3. I'm looking through this question, and I'm seeing a sine and a cosine, which tells me I can't isolate anything, but I could factor something. We are going to factor out cosine, but before I dive into factoring, I got to just double check. Is this set equal to 0? Now I'm ready to factor. So I heard I could take out a cosine. Let's do that. That leaves me with sine minus 3. So I'm all factored. Take your factors and set them equal to 0, and let's go visit the unit circle. So you got cosine equals 0 for the first factor set. And then you got sine x minus 3 equals 0 for the next factor set. This one's good to go. I'm going to take a peek at the unit circle in a moment, but let's talk about this one. It says sine equals 3. And I think we have the same issue that we had on the previous question. Is your sine going to hit 3? No, it's not. So this is garbage. Well, sine outputs are only, unless it's got some weird numbers with it, it's only defined between negative 1 and 1. So it won't get to 3 out of its range. These are not, yeah. So its ratio would always come back down to a 1. Yeah. Like the side, like if you think of it in terms of triangles, like it might be 6 over 6, and it reduces to a 1. Okay. So talk to me about your unit circle then. Where is your cosine 0? Yeah? And also there. All right. So, yeah, now you're diving into book territory. Hold on, man. All right, so I am going to write down pi over 2 and 3 pi over 2, and then lazy Abruzzo is going to go plus 2 pi n on each of these, and I'm going to call it a day. But then there's the other kids. Daniel, apparently you're that kid.
Yeah.
What did you say? Yeah, and that's right. Plus pi n, but yeah. I like that. Some people, right? Plus and minus pi over 2 is pi n, which I'm like, it's kind of the same thing. So I don't know why they're bothering. I'm with you. I like the answer.
Yeah.
And I would not cut you wrong because you're totally not wrong. I just don't know why you'd want to do that. But you already had to find that one. Okay. Oh, very dramatic. My silly little mind can't handle that. Some days. So tell me, silly little minds of the world, what do you tell the kid who's like, I'm gonna divide by sine. I'm gonna divide by sine because that's a thing I can do. Oh, we cannot divide by sine. That's like one thing I can't do. So we're supposed to isolate one side, set it equal to 0. This needs to equal 0 first. So we're going to subtract sine squared, or sine over, excuse me. You can. Why would you do that? You're like extra strained today. All right. So we did factor, or we're going to factor, I should say, but first we had to make sure it was set equal to 0 before we did any factoring. All right. Now tell me how you're going to factor this baby. Very good. So removing a sign from that. You still have, 2 sine squared. Don't worry, it'll work out. Minus 1. And now that we're all factored, it is a thing. Yes, if you remember. Oh, interesting. You wanted to, okay, keep that in mind for a later problem. I don't think we need to trade it. The other issue is this is a 2, so it's not cosine squared. No. If this was a 2, we'd have a different story, but your idea about trading, very important on the next page. So, all right, so sine of x equals 0. This one's ready for the unit circle, but let's talk about this guy. 2 sine squared x minus 1 equals 0. Not ready for the unit circle. Gotta do some solving here. You're going to add the 1 over. You're also going to divide by 2, right? So sine squared x equals 1/2. I'm still not ready for the unit circle, guys, because sine squared is not a thing on the unit circle. Square root both sides. Daniel, it's your moment again. Well, you're square rooting a 1 over 2. You got to rationalize. Isn't it that? Well, it probably bothers you that I call it square root of 1. What is the square root of 1? It's just 1. So when you square root that fraction, you got 1 over square root of 2. And then math doesn't like that, so you rationalized by hitting top and bottom by square root of 2. Mm-hmm. Right. So this might be the one exception, though, because if you're referencing a unit circle, if they keep calling it square root of 2 over 2, you're not going to know what that means, you know? So this might be the exception. I don't know. I mean, it's not a horrible rationalization. The act of rationalizing was really necessary only when they had to go back and look at reference charts to find things. Because like before calculators, when I said, you know, what is the sign of something crazy, like they had to go back to a chart and look it up, which was horrible. I have to do that? No. I just told you my story about how I lost my TI-83 calculator in my backpack when I it was high school. Those calculators were very cool back then. Oh my gosh. That color screen came out, man. That was a life changer. All right. Oh boy. Guys, we got a lot of listing to do. Let's start with where is sine equal to 0? On one trip around the unit circle, first of all. Oh, pi and 0. Yep. We'll come back to that idea. Oh my goodness. Sine, positive or negative, square root of 2 over 2. Y'all, that's everybody in what family? supposed to be in the middle of the quadrant. I kind of missed. It's everybody in the pi over 4 family, isn't it? So, oh boy, here we go. I'm going to list them over here so they're underneath each other. X equals pi over 4 and 3 pi over 4 and 5 pi over 4 and 7 pi over 4 and, yeah, all solutions. So I'm going to do the thing I told you you're not supposed to do. All of those plus 2 pi n. Now, you know there's an easier way to write this. There has to be an easier way to write that. Come on, that's just crazy. Let's start with the 0 and pi thing. Give me a shorter way to write that. Well, if you, oh, like these answers? Oh, this part, okay. If you're like a little bamboozled by this next step, that's okay. I just, my silly little brain can't handle this. So 0 and pi, 0 and pi, 0 and pi. It's just going to be multiples of pi over and over and over again. So the simpler way to say that would be pi n. 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Then, okay, so let's talk about these green guys over here. The pi over 4s. This is positive pi over 4, and this is negative pi over 4, right? So the way your book would write this is they would say plus and minus pi over 4 plus pi n. Now, why is it pi n? Let's talk. So this guy is positive pi over 4, and if you add a rotation, half rotation to him, you get here. This guy is negative pi over 4. If you add a half rotation to him, you get those guys. So they're like their own families, and it's very confusing. You can say pi over 4 plus pi over 4n. That would also be equivalent. Yes, thank you. Pi over 2n. Good call. Yes, pi over 2n. Good point. Yes. My silly little brain. So my point comes back to, was it worth your time to come up with those simpler ways? Right? Right. Right. I'm with you. I know, it's potato. I just really like to say that phrase wrong constantly. You're supposed to say potato potato. I often say potato tomato. It's funny. And today it's potato potato. Let's be honest, guys. This whole thing is a potato. This is not a fun day. It's stupid and I hate me ass. Why are you going to PreCalc? Drop it. Because my dad wouldn't let me drop it. All right. Hey guys, good news. The next few, they just want 0 to 2 pi. So you're just going to make a trip around the unit circle and call it a day. Now, one thing I will point out to you, non-inclusive parenthesis on the 2 pi. So the dreaded 0, 2 pi option, don't tell me 2 pi, because that would be wrong. A lot of people like to tell me 2 pi when they get to that radian measure. So like if your answer comes out to this, a lot of kids tell me 2 pi, and they can't because of this non-inclusive parenthesis 0, and that's it. I get kids who are like 0, 2 pi. That's wrong. I know. Feels like it should be. Gut instinct, algebra instinct kicking in on number 5. What are you thinking? Why? So here's what I noticed. There's only a there's only a cosine function in this whole problem. Like that's it. You should isolate him. So a word on my, yeah, I would have written down the word isolate on your answer key if you were like, I don't know what to do. Isolate. So the reason we're not trying to bring everything to one side and side equal to 0, this is not a factoring question. There's only one cosine function in the whole problem. So there's no point in factoring. If you would have moved the 1, you would have had 2 cosine x equals 1. No, minus 1 equals 0, excuse me. And then you would have had cosine x minus 1/2 equals 0. And then you would have had to add the 1/2 back over. Which we're going to get to the same place. So tomato, tomato again. All right, cosine x equals 1/2. Tell me, in one rotation of the unit circle, every place that you see cosine of 1/2. Cosine equals 1/2. Pi over 3. Nope, it's between 0 and 2 pi. Good question, though. So this guy, and I need you to give him the proper name. Yeah. And that's it. Nice. No plus or minus business because it just wants one rotation. Okay. So this next one looks really crazy, but again, I only see a single sine function in the whole dang problem. So this is another isolating one. You're going to add 7 and subtract 5, so you're really just adding 2. So you got 2 sine x equals 2. So divide by 2 on both sides, and sine x equals 1. Where are the places where sine is 1? How about this one? Why would I not include 3 pi over 2 in that? That's -1. Drat. I tricked you by saying places. That was evil of me. And slightly intentional. Tangent! Oh no! Remember that first question you guys watched me do? And you're like, God. Yes. 0 and 2 pi are the same place. So I wouldn't put an inclusive 2 pi on there because you'd be giving me the same, it'd be a rotation of 0. It'd be overkill. When I want singular solutions on one sine cycle or one cosine cycle, 0 and 2 pi. 2 pi is the start of the next cycle. Okay. All right, now, tell me what I should not do on this question. We should not divide by tangent. That's right. That's what he said. That's illegal on any planet. You can't divide by tangent. Now, in the back of my brain, I'm going, don't forget, tangent is my arch nemesis, and things happen. If we end up getting one of two answers, if we end up getting this guy or this guy, I got to remember that tangent is undefined here and here, so just keep that in mind. I don't think it happens on this question. Yes. We should. Yes, we're going to factor this one, which means we first need to set it equal to 0. So, subtracting tangent over, you've got 4 sine squared x times tan x minus tan x equals 0. Now we're real set up to factor. What's the common factor here? Tan, yeah. Tangent. All right, factoring out a tangent, you still have 4 sine squared minus 1. Now that we are factored, we're going to take our turn setting each factor equal to 0. This one's going to be ready to go for the unit circle. This one's going to take a little work. Not that much work. Tell me some steps I have to take. Add the 1. Also, divide by 4. I'll do that in one step. And then we're going to square root. And then I'm going to tell my teacher, oops, can't lose the sine function though, guys. Sine x equals square root this. 1/2, yeah. This one doesn't need rationalization because 1/4 is 1/2 in the square root. All right, so I'm ready to look at the unit circle for both of these equations. Here goes. And remember, I just want one rotation of the unit circle. Tell me a place where tangent would come out to 0. Remember, tangent is sine over cosine. So think about that. You could also think of the graph of tangent. Tangent goes through the origin. So at 0, you would get tangent 0. And also at pi. Where is sine positive or negative 1/2? You got a family here. You got this guy and this guy, the pi over 6s, I think. Yeah. So we're going to add to this list, and we're going to say x equals pi over 6, 5 pi over 6, and 7 pi over 6, and 11 pi over 6. Now, I could have just listed all those out in one line, because I forgot we weren't doing the plus and 2 pi n thing. So 1, 2, 3, 4, 5, 6 answers. And then I'm really paranoid because I hate tangent. Did we end up getting the 2 things we weren't allowed to have for tangent? Tangent can't be pi over 2 or 3 pi over 2. or excuse me, the tangent is not defined at 3 pi over 2 or pi over 2. And we didn't get any of those, so we get to keep all of our answers. Good news. All 6 of them. Interesting choice to put your head down during my lesson. Oh my gosh. Wowzer, guys. Here's what we're gonna do. We're gonna skip a little bit. There's some worked out examples here, guys, and they're telling you we're dipping our toes. We're dipping our toes into what's going to be considered the harder kind of equations that we're solving. This is really Tuesday's lesson we're working towards, but hang with me, guys. Look at that. I know it's already done for you on your paper, but tangent squared, secant squared, and then a random tangent at the end. That can't be good. Guys, we can't handle that. There's no way we can approach that using algebraic methods. So we have to do a trig trade. Here's what they did. They said, hey, don't forget, secant squared is equivalent to tangent squared plus 1. So they took the secant squared right here, and they swapped it out for tangent squared plus 1. That allowed them to have an equation that has all tangents in it. And after doing some moving around and setting everything equal to 0, they ended up with this. Guys, this is not a take your common factor out kind of factoring. This is the old reverse foiling kind of factoring. We're going to have to do that. So what times what is tangent squared? That's tangent and tangent. And then 1 times 1 is 1. And then the arches would add up to 2 tangents. Now, they took the liberty of writing it as tangent plus 1 quantity squared instead of 2 separate factors. So that's what we're going to have to be doing on part of our homework too. So the other thing I want to point out to you that they did was right here. The original problem was 1 plus cosine equals sine. And like, there's nothing you can do there, guys. Like, you can't trade anything. So they create Pythagorean trades by simply squaring both sides. And I know you're like asking yourself, like, am I allowed to do that? Yes, you do it all the time. When you have square root of x equals 4, what do? You square both sides. Like, you do this all the time. You can just randomly square things. Yeah, you've always been able to do that. So when you square both sides, yes, no, you can't divide by function, but you can square root and divide by things, just not function. So here, guys, they create Pythagoreans, which allows them to then actually go and solve. We're going to do more of these on Tuesday. This is dipping our toes into the hard ones, right? Dipping our toes, just a little brief intro. You guys are totally going to do your homework for me. Yes. That's talent. Have a great weekend. Have a good Valentine's Day. Yeah, here. Bye-bye.